IntelliMAX Advanced Load Management Switches by Fairchild Semiconductor. Welcome to the training module on Fairchild IntelliMAX Advanced Load Management Switches. This training module introduces the IntelliMAX Advanced Load Management Switches and their key features. The IntelliMAX family combines conventional MOSFET performance with a unique combination of protection, control, and fault monitoring features to enhance power management design. This level of integration helps designers achieve efficiency and reliability while minimizing board space requirements. This family has wide operating voltage range, which fulfills today's portable devices supply requirements. It also has other features including slew rate control, under voltage lockout, overcurrent limit protection, thermal shutdown, and fault monitoring. In this slide we have a functional block diagram for IntelliMAX family. It consists of different protection circuits such as short circuit and thermal protection, and current limiting protection, turn on and inrush control block, and reverse current blocking circuit. However, not every member in this family contains all these features. As the IntelliMAX family features a wide operating range from 1.2 volts to 5.5 volts to address the voltage specifications for most portable devices such as mobile phones, PDAs, digital cameras, MP3 players, and portable barcode readers. These load switches have low quiescent current, which helps to prolong battery life. Here we list a series of applications supported by IntelliMAX load switches. The current limit ensures that the current through the switch does not exceed a maximum value, while not limiting at less than a minimum value. When the load current exceeds the maximum current, some load switches have a blinking time during which the switches will act as a constant current source. At the end of the blinking time, the switches will be turned off and the fault flag pin will be activated to indicate that the current limiting has occurred. If the load switch has no current limit blinking period, immediately upon a current limit condition, the fault flag pin is activated. These parts will remain in a constant current state until the on pin is deactivated or the thermal shutdown turns off the switch. The under voltage lockout turns off the switch if the input voltage drops below the under voltage lockout threshold. With the on pin active, the input voltage rising above the under voltage lockout threshold will cause a controlled turn-on of the switch, which limits current overshoots. If the device is in the under voltage lockout condition, the fault flag goes low and indicates the fault. If the voltage at the Vout pin is larger than the Vin pin, large currents may flow and cause permanent damage to the device. The load switch is designed to control current flow from Vin to Vout, so the reverse current blocking prevents current from flowing when the MOSFET is off and the output voltage is higher than the input voltage. The slew rate control feature turns the switch on over a defined period of time, which limits the current through the device and into the load. When balanced with load capacitance, this feature helps to prevent current spikes on the load and minimizes voltage sags on the input. The thermal shutdown protects the device from internally or externally generated excessive temperatures. During over temperature condition, the fault flag is activated and the switch is turned off. The switch automatically turns on again if the temperature of the die drops below the threshold temperature. Upon the detection of an overcurrent, an input under voltage, or an over temperature condition, the fault flag signals the fault mode by activating low. If the device has a blinking time and the fault condition persists beyond the blinking time, the fault flag goes low and the switch is turned off at the end of the blinking time. If the device does not have a blinking time, the fault flag goes low and the switch is shut off immediately. The fault flag is low during the faults and immediately turns high at the end of the fault condition. The fault flag pin is an open drain MOSFET which requires a pull-up resistor between VN and fault flag pin. During shutdown, the pull-down and fault flag pin is disabled to reduce current draw from the supply. Switch control is by logic input on capable of interfacing directly with low voltage control signal. The on pin controls the state of the switch. Active high and low versions are available to accommodate various application requirements. Refer to the datasheet for details. Applying a continuous high or low signal depending on the switch configuration will hold the switch in the on state for as long as there is no fault. The load switch will move into the off state when the on pin is inactive. For all versions, an under voltage on Vn or a junction temperature in excess of rated temperature overrides the on control and turns off the switch. For an overcurrent condition, there are two responses. Please refer to the datasheet for details. One case is that the load switch moves into the off state if a current fault is encountered for longer duration than the blinking time. Another is that the load switch does not turn off in response to an overcurrent condition, but instead remains operating in constant current mode for as long as the on active and thermal shutdown or under voltage lockout have not activated. To limit the voltage drop on the input supply caused by transient inrush current when the switch turns on into a discharged load capacitor or short circuit, a capacitor C1 needs to be placed between V1 and ground. An output capacitor C2 should be placed between Vout and ground to prevent parasitic word inductance from forcing Vout below ground when the switch turns off. For best performance, all traces in the PC board should be as short as possible. To be most effective, the input and output capacitors should be placed close to the device to minimize the effects that parasitic trace inductances may have on normal and short circuit operations. Using white traces of Vin, Vout, and ground will help minimize parasitic electrical effects along with minimizing the case to ambient thermal impedance. Different packaging solutions in this family are available. Some include WL-CSP, MLP, SOT23, and SC70. In this chart, we show the different dimensions for the different packages.